This is problem number 7 on the practice problems for test number 2. You have a choice between getting paid $9,000 today, $11,000 in 10 years, or $1,000 per year distributed continuously throughout the next 10 years. Assume that all money will be placed in a bank account that pays 2% annual interest compounded continuously throughout the 10-year period. Find the present and future values of each payment option and state which form of payment is best and which is worst. So we're going to go ahead and make a table here. We're going to calculate the present value and the future value for each of these 3 options. So the first one we'll do is going to be the $9,000 today. Oops, one more column here. Okay, so the first one is $9,000 today. So the present value of $9,000 today is $9,000. The future value we'll come back to. Let's go to the next option, which is $11,000 in 10 years. So the present value is a little bit of work, but the future value in 10 years of $11,000 in 10 years is easy. It's $11,000. Okay, so let's go ahead and fill in the 2 blanks that we've got for these 2 rows, and then we'll do the tough one, which is down at the bottom. So $9,000 today, future value is just a formula. Future value of just a single payment is given by PERT. No calculus here, it's just a one-time thing. Calculus will come in with the 3rd option, which is the income stream. So $9,000 e to the 0.02, that's 2% annual interest, and then 10 years into the future, that's how long we have to wait. Type that into the calculator, we get about $10,992.62. The present value of this $11,000 in 10 years is also easy. It's just a single formula. It's basically this formula, but solved for P, the future value compared to the principal, which you can think of as a present value. So the present value formula is, it's the future value times e to the negative RT by dividing both sides by e to the RT. But I'm not going to use FV, I'm going to use B. That's the letter your book uses. So in this case, we have $11,000 times e to the negative 0.02 times the same 10 years. And we can type that into the calculator. Turns out to be about $9,006.04. So right away we can at least compare the 2 non-calculus options. In the top row, let's actually look at the present value column. So your choices are either something which has a present value of $9,000 versus something which has a present value of $9,006. We pick this one, it's bigger. The future values should agree with that. In the future, you have an option of either something that will be worth $10,992.62 or $11,000. We pick the bigger one, and of course, it's consistently bigger in that row. But now we'll do the calculus one, which is this income stream. So here, the option is $1,000 per year for the 10 years. And if you watched the video for the previous problem, you saw it was a lot of work to deal with how much work was required to move a bunch of water in a strangely shaped tank. Here, this is pretty straightforward. There is a simple calculus formula that we can use. I'm just going to write it down. In some sense, it feels like bailing out compared to all the work that we did in the last problem. But there is a project which you are either currently working on or maybe have just finished working on, project number 6, where you will have a chance to actually think about the slicing in a present future value problem like this, dealing with an income stream. So right now, we're just going to bail out and use the formula. So here it is. Present value is equal to the integral from 0 to m, where m is the number of time units that pass, p of t, where p of t is the income stream, e to the negative rt dt. So we'll plug stuff in, integral 0 to 10 years. The income stream is $1,000 per year. That could have t's in it. In this case, it's just a constant $1,000 per year. E to the negative 0.02 t dt. Maybe good practice to try to find this integral, or at least do the antiderivative without any technology. I'm just going to write down the answer that I got from typing the thing into the calculator. So that's worth $9,063.46 today. And in the last column, we're going to find the future value. Again, there's just a calculus formula that we'll use. So here it is. It's integral 0 to m p of t. Again, the income stream e to the, and now this becomes kind of funny. It's r times m minus t. That m minus t represents how much time is left, how much time the money has to grow. So we'll just plug in 0 to 10. Again, the income stream is still 1,000 constant, but it could have t's in it. E to the 0.02 times 10 minus t. M is 10. Again, it would be good practice to try to find an antiderivative without any technology. I'm just going to type the, or write the answer I got from my calculator. So comparing these, we see that your present value is 9,063, which is better than 9,006 and better than 9,000. So it seems like the last row is the best option. Let's see if the future value agrees with that. In the future, it's worth $11,070, which is better than 11,000 and better than 10,992. So in this case, the income stream is the best. Now, which one is the best is also dependent on the interest rate, and might be good to explore what changing the interest rate, what effect changing the interest rate has. If you decided to make that 2% a 5%, all of a sudden maybe the bottom row isn't the best one. If you changed it to a 1%, if you changed it to 10%, it might be good, just a good exercise. If you're interested in exploring this, what kinds of percentages make the first row the best one, the $9,000 today? What kind of percentages make the $11,000 in 10 years the best? And what kind of percentages make this $1,000 per year the best? So just something to think about if you're interested.